Well, hello, Honors Algebra 2. I think this unit circle discovery it's a challenging thing to get through. So if you truly work through it and got it all right, then kudos to you. It's not something that's easy. Had we done this in class, we would have probably taken about half the class period, and I would have kind of been giving you hints along the way. Since I'm not able to do that, instead I'm going to actually work through the entire thing and record myself doing it. That way, if you were stuck at a particular part, feel free to fast forward to that part and then just kind of watch the video out from there. Our goal by the end of this discovery is going to be able to fill out this kind of massive circle. And there's a lot of stuff on it, but it's a very useful circle, something that you'll be using probably for the next 2 to 3 years of your math classes. So not only honors pre-calc and college algebra trig, all the way up through calculus, either A, B, or B, C. So very important stuff here in this unit circle discovery. So for the first part, determine the missing sides for the following special right triangles. Well, the first one is a 30, 60, 90 triangle. So you just had to remember what the ratios of the sides were. So for your shorter leg, that is going to be your hypotenuse divided by 2. So that would be 1/2. And for the longer leg, you would have taken your shorter leg multiplied by the square root of 3. And then you can simplify that and just write it as the square root of 3 over 2. Okay. Second triangle, 45, 45, 90-degree triangle. So you just had to remember the special ratio for that triangle was that you take your hypotenuse and divide by the square root of 2. And then to rationalize that, you would then multiply by the square root of 2 over the square root of 2. And that would tell you that your side length was the square root of 2 over 2. Now, since it's a 45, 45, 90, you've got your two side lengths, which are the same. And since square root of 2 over 2 would have been the same for both. The last one was actually also a 30, 60, 90-degree triangle. It just had its kind of base with the 60-degree angle instead of 30. So you can actually just copy over those same side lengths that we found on that first triangle, just in the different places. So making sure 1/2 is shorter side and square root of 3 over 2 is the longer side. Okay. The next part, hopefully you're able to get this part. This actually just came straight from the very first day of notes for this unit, which is that there are 2 pi radians. Well, I guess it's a semicircle. So pi radians in the semicircle and 2 pi radians in the entire circle. So then as far as labeling the following, you should have had 0, let's see, in both degrees and radians. Let's do degrees first since those are a little bit easier. And I'm going to just kind of go around and label these. I'm going to go pretty quick. If you want to see these labeled a little bit more slowly, feel free to go to Schoology or YouTube, check out my other video that I've got up there for you, and it gives you a little bit more explanation as to why these are what they are. I'm just going to copy these in so that we can use them later. So here is your first triangle, or your first circle rather, in terms of degrees. And then in terms of radians, you should have been going around by pi over 6s. So you've got pi over 6, and I'm not going to simplify. Later on we will simplify, but for right now, I'll just kind of leave it unsimplified. So 4 pi over 6, 5 pi over 6, all the way up to 6 pi over 6 at 180, and then just keep counting around. So 7 pi over 6, 8 pi over 6, 9 pi over 6. And we're almost all the way around. And finally, 12 pi over 6, which again is the same as 2 pi. Okay, next circle. Go ahead and count these around in degrees first. So 0, 45, 90, 135, 180, and then 225, 270, 315, back around to 360 degrees. And then in terms of radians, you were counting by pi over 4s. So this would have been 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4, which would have been the same as 2 pi. And if you wanted to go ahead and simplify those, feel free. Okay, last one here. So going around for degrees, we had 0, 60, 120, and then 180 degrees. Here's 240, 300, and 360 degrees. And then in terms of radians, you were counting by pi over 3s this time. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3. Okay, so again, I kind of went through that pretty quickly. Again, if you would like a little bit more explanation as to how we were coming up with those values, go back and check out that section 9.1 notes video that's on Schoology and YouTube for you, and there's a little bit more explanation that I give there. Okay, so number 3 is we kind of continue to build towards that large circle. We're going to use the ideas above to investigate what's called the unit circle. The unit circle is special because it has a radius of 1 unit. We're going to now label the coordinates of the following points along the unit circle, assuming that the circle lies in our normal coordinate plane, and also assuming that the center for your circle is at 0, 0. And so if your radius is 1, if you go to the right by 1, that would be the point 1, 0. If you go up by 1, that would be the point 0, 1. If you go left by 1, that would be -1, 0. And down by 1 would be 0, -1. Okay. So, moving on to the next part here. What would the coordinates be for the point below? Think about the special right triangles we discussed earlier. Could you extend it to other points along the circle with the same reference angle? Okay, so here's kind of the idea of this. Taking a look at this first circle is to make a triangle by drawing down a line from that point. What that ends up becoming then is you've got a right triangle with a 45-degree angle, a 45-degree angle, and guess what? We've already found those two side lengths. We found those two side lengths in this second triangle right here, which were square root of 2 over 2 and square root of 2 over 2. So this would be a side length of square root of 2 over 2. This would also be a side length of square root of 2 over 2. We can also think about those as coordinates. Really, the x-coordinate would be that you move to the right by the square root of 2 over 2. The y-coordinate would be that you moved up by the square root of 2 over 2. So in other words, that point along the circle would be at square root of 2 over 2, comma square root of 2 over 2. Now that doesn't just work in the first quadrant. That actually works in all of our quadrants. And so if you go to the next circle, here's the idea, is that these are still the same lengths. It's just now we're actually going to talk about direction as well. So the y value for this point right here would be square root of 2 over 2, but the x value, since you move to the left, would actually be negative square root of 2 over 2. Moving on to the next point here, again, your x value is still negative square root of 2 over 2 because you moved to the left. You also moved down, so that y value is also going to be negative square root of 2 over 2. And then the final one in the fourth quadrant is going to be that we moved to the right, so that was a positive direction, square root of 2 over 2 for the x value. But then we moved down by square root of 2 over 2, so that would be a negative square root of 2 over 2 for your y value. Okay, so what would the coordinates be for the point below? Think about our special right triangles we discussed earlier, and could you extend it to other points along the circle with the same reference angle? So really, this is just more of the same, just using the other right triangles that we looked at earlier. So the first example is where we had a 30, 60, 90 triangle, where we said that this was a length of 1/2, this was a length of square root of 3 over 2, and again, similar to what we did above, there's your x value, there's your y value. So now you've got square root of 3 over 2, comma 1 over 2 for your point. And then similar to what we did on the second circle, we're now just going to generalize that to all of the other points. So starting with the point that we just finished with, which was positive square root of 3 over 2, comma 1 over 2. Really, let's go down to the fourth quadrant, maybe that might make it a little easier, is to think about the fact that your x value is still the same. The only thing that's different is that your y value is now negative. Let's go over to the third quadrant. So now think about what's the same as the point we just finished with, which should be the y value, is that we went down by negative 1/2. The one that's going to be different, though, is instead of going to the right by square root of 3 over 2, we'd go to the left by square root of 3 over 2. So that would be a negative. And then for the point now in the second quadrant, x value is going to be the same as the point we just did. The y value is now just a positive 1/2 instead of a negative 1/2. Okay. One more circle to go, and then we're going to add everything onto the large circle. So our last one here, we're thinking about now a similar triangle than we just looked at. The only difference being now it's the 30-degree angle at the top of the triangle and the 60-degree angle as the base angle. So now the only thing that's really different is your sides are switched around. So now 1/2 is your x value and square root of 3/2 is your y value. So again, translating that on to the next circle, we're going to keep that the same for your first quadrant. And then really the other points are the same all the way around. We just have to be careful with what signs they are. So that's what I'm going to actually do right now is I'm just going to copy all those points down. Then we can talk about what the signs should be. So the point right here in our second quadrant should have a negative x value and a positive y value. For this point in our third quadrant, that should have a negative x value and a negative y value. And you can probably see how much quicker it is once you kind of understand that relationship. So quadrant 4, positive x value, negative y value. Okay, so we should at this point have all of the pieces to be able to fill in our much larger unit circle at the very end here. So basically what you want to try to visualize is taking each of these individual circles that we just filled out. And so we filled out 4, this was 5, 6, 7 different circles. And we're going to fill it all into one single circle. For right now, we're not going to worry about the positive and negative. I'll kind of share that with you next week when we do our video on how to use this unit circle. For right now, we're just trying to build the unit circle. So let's go around and let's label it in terms of degrees first. And so putting all those separate circles together, this would be 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So you're going back to those circles from the second section and kind of filling in what the degrees are that match up with this circle. Continuing our way around, this is 120, 135 degrees, this is 150 degrees, and obviously at this point 180 degrees. Okay, continuing with those, this would have been 210 degrees on the other circle, 225, 240 degrees, all the way around to 270 degrees. And then finally for our fourth quadrant, we would have had 300 degrees, 315 degrees, 330 degrees, and 360 degrees. Okay, so that takes care of all of our degrees. Next, let's fill in our radians. And I'm going to go ahead and simplify these even though we didn't before. So this would have been 0 radians. This is pi over 6 radians. This was pi over 4 radians. This was pi over 3 radians. And then this was pi over 2 radians. Okay, so now you've already noticed that when I got to pi over 2, I'd simplified that, as well as pi over 3 would have been 2 pi over 6, so I simplified that as well. I'm going to continue to simplify those as we go around. So this would have been 2 pi over 3 radians, 3 pi over 4 radians, and 5 pi over 6 radians, to where eventually you get back to pi. Okay. Continuing our way around, we are now at 7 pi over 6 radians once you've simplified. This would have been 4 pi over 3, or excuse me, that's the next one. So this should have been actually 5 pi over 4 radians, and then here is the one that I was thinking of, which is the 4 pi over 3 radians. Just hadn't gotten there yet. Finally, you get back around to 3 pi over 2 radians, and now we've just got one more section to go. So this would have been 5 pi over 3 radians. This would have been 7 pi over 4 radians. This would have been 11 pi over 6 radians, all the way back around to 2 pi. All right, one last thing to go. We just got to fill in the coordinates. So all those circles, or all those points from our second page, we're now going to fill in. Don't forget about the ones that are at kind of the corners. So this would have been the point 1 comma 0. And then at this point, we've got square root of 3 over 2, 1 over 2, square root of 2 over 2, square root of 2 over 2, 1 over 2, square root of 3 over 2, and 0 comma 1. So there's our first quadrant. Second quadrant. And remember, most of the points are kind of going to stay the same. It's just their signs that are going to change. So this would have been the same as 60 degrees, just with a negative 1/2. This is going to be the same as 45 degrees, just with a negative square root of 2 over 2 for the first coordinate. And then this is going to be the same as 30 degrees with a negative square root of 3 over 2 for the x value. All the way around to our next kind of whole number value, which is at negative 1 comma 0. All right, so first two quadrants are done. Here comes the third quadrant. So everything in the third quadrant should be negative. So negative square root of 3 over 2, and negative 1 over 2, negative square root of 2 over 2, and negative square root of 2 over 2. This would have been negative 1 over 2, negative square root of 3 over 2, and this would have been at 0, negative 1. Okay, so there's third quadrant, almost done. Fourth quadrant, positive x values, negative y values. So you've got positive 1/2, negative radical 3 over 2, positive square root of 2 over 2, negative square root of 2 over 2, and positive square root of 3 over 2, negative square root of 1 over, or negative 1 over, negative 1 over 2. Yeah, there we go. Okay, so here's the deal, guys. You need to know this circle. In fact, my encouragement to you is to memorize it. If we were in class, that would have been a requirement for this quarter. And I will tell you that for especially those going to honors pre-calc next year, Mrs. Davis and I have talked about this. The students who are able to memorize it and do it quickly are the ones that do best in her class. So please make sure you're taking the time and doing this. I'm going to post a website that gives you a place that you can actually practice kind of pointing and clicking on the different values that would help you start to memorize it. In years past, we actually used to time it to see who could actually not only memorize it, but do it the quickest. And we've gotten to where pretty much every single person who's been in my class has memorized it and been able to do it in under 5 minutes. In fact, the quickest have been able to do it in less than a minute and a half all the way around. So we'll try to do something similar, kind of a competition style thing, and I'll get the details of that worked out. For right now, the only thing I want you to do is continue to look over the circle, make sure it makes sense for all of those angles, where all of those coordinates came from, and if you have any questions, make sure and show up to my office hours. I'd be more than happy to talk you through it. That's all I got for you today. Have a good rest of your day, Honors Algebra 2, and I will talk to you again soon.